Hello everyone, I'm Jay Joshi and welcome to episode 32 of Learning Java. Today, we'll be looking at another example of recursion. So this example, unlike the last one, involves some of the other concepts of backtracking and recursion. And this example of recursion is very tricky. So if you manage to solve this example on your own, you know recursion very well because this tests every single fundamental of recursion. So let's have a look at this program. So this is a simple program with a normal class practice recur, and I have a main. So in the main, I have a function fun. The name of the function is fun, and the parameter is 4. So the function fun is initialized over here. It's a static function which does not return anything. That's why there's a void over here. So public static void fun, and in the parameter, there's int x, which is 4 over here. So x is 4. So the base case in this recursion function is if x is greater than 0. And it's a recursive function because the function calls itself. So you can see the name of the function is fun and it's calling itself twice that too. And so if the condition is true, if x is greater than 0, so the thing will execute till x is greater than 0. So x should be 4, 3, 2, 1. So first, this function is called again with a value lesser than that of x. Then it prints x and then it calls the function again. So although this seems simple, when we do the dry run, you'll actually see the amount of backtracking and something else that takes place in recursion, which you'll see now. So let's have a look at the dry run. I have pasted a snippet over here, and now let's go through the dry run together. So first we have fun4. So first fun4 is called. So we have fun, and the parameter x is 4 right now. So when this function fun4 is called, first it'll check if 4 is greater than 0, which it is. So then it goes to the next line, fun of minus minus x. So it calls the function over here fun of minus minus x, which is 3. It uses the value 3 because this is a prefix operator and it's use, change and then use. So first it'll change the value and then it'll use the value. So now when this fun of 3 is called, this should carry on with the function fun of 3, right? But then what happens to these two other statements, the system.out.println and another fun call statement? This is where the confusion comes in. So think of this fun in the first part just like a normal statement. Let's say this, instead of this fun, there was another system.out.println statement. What you would do is you'll first execute the sopln statement and then move on to the next line. In the same way, first this fun thing will get executed. So all the recursive functions inside this fun of 3 will get executed first, and then this SOP will get executed. So these two, the SOP and this another fun, will happen after this fun 3 is executed. So what we can do is we can put them on the side. This is a technique, so you're reserving this for later. This is not how the computer does. First it'll do this internally and then it'll go to this. But for our reference, we are putting it on the side so that we don't forget it. And at the end, when we backtrack it, you'll understand it better. So first this fun 3 will get executed and we are just putting this SOP and this fun on the side. So the current value of x is 3. So it's printing SOP 3. And then it calls the function fun again. Fun, and this time it's minus minus x again, so we'll call fun of 2. Now this is on the side. This doesn't get executed right now. First, this fun of 3 is getting executed. So let's move on with this. In this fun of 3, first we'll check if 3 is greater than 0, which it is. So then it'll move on to fun of 2. Then again, on the side, we'll put it for a reference, SOP2. So SOP, it prints 2, and then fun of 1. A space also gets printed off this SOP, which I'm not putting. I'll put it at the end when we do the output. Now this fun2 gets executed. So under fun2, we'll have fun, and this time it'll be fun1. And on the side, we'll have fun. We'll have first the SOP statement. So let me erase this. Okay, so we'll have the SOP statement, SOP1, and then we'll have fun of 0. So fun of 0. Okay, let me put this back. All right, so we are almost done with this thing. Now this is the final thing. So for it'll check 1 is greater than 0, which it is. So the final recursion will take place like this. So fun of 0 then it'll print 0 over here, SOP0, and then it'll call the function fun again with one value lesser. So this time it'll be fun of -1. Okay, now this function will still carry on. So fun of 0, it'll check if 0 is greater than 0, which it's not. So the function will stop over here. So this will terminate over here. Now we go to the backtracking state. So I'll use a red pen for this. This is the tricky part. How do we backtrack in this case? So in this fun of 0 function, after this fun of 0 function is executed, nothing else is done. But after this fun of 0, there's SOP0 and fun of -1. So I'll write the output over here. This is the output section. So first it'll print SOP0 because the recursive function has ended over here. And then it'll call the function -1. And since -1 is not greater than 0, nothing else will get executed. So this is done. Then it'll backtrack to fun of 1 from here. In fun of 1, after fun of 1 is executed, so this all comes under f fun of 1. This SOP will get executed. So SOP1, so it'll print 1. And then this function of 0 will get executed, fun of 0. And since 0 is not greater than 0, nothing will be done. So this is done. Then it'll backtrack again to fun of 2. Under fun of 2, we have SOP2. So it'll print 2 over here. And then it'll call the function fun1. Now, this fun1 will now execute normally. So when fun1 is called, we can see over here when fun1 is called, fun of 0 is called, SOP0 and fun of -1. So SOP0 gets printed over here. Now, again, this backtracks to fun of 3. First, SOP3, so 3 will get printed, and then it'll go to this fun of 2. Under fun of 2, we have fun of 1 and fun of 0. So it'll execute this full thing again, which is under fun of 2. So it'll print 0 first. Then it'll go under fun of 1. So it'll print SOP1 and then nothing gets executed over here. And that's it. And over here, again, finally, it just goes to this. This is already done. So this is how the full recursion is taking place. And this is our final output, 0, 1, 2, 0, 3, 0, 1. So let's just cross check if this is correct. So let's do void main and we get 0, 1, 2, 0, 3, 0, 1, which is correct. So what's happening over here is first it goes normally, and the main trick over here is to write the statements after a recursion thing is called on the side. And at the end of it, you first do this part. So let me change the ink again. You first do this part and then you backtrack again. Then you do this part, you backtrack, and this cycle keeps on going. And if there's a function over here, then this function, if you want, you can again just do everything again, or you can just refer to this fun of 0 and everything. So it's the same cycle again and again, and we get this final output in this case. So you can see how this simple 4-line code can lead to such a complicated output and try run. So this code essentially tests all your concepts of recursion. You can see how there's things on the right, there's a bit of tricky backtracking and everything, and there are 2 function calls within the same function. Now, what I would recommend is you try to do the dry run of this code on your own without looking. And if you manage to do that, this means you know the concept of recursion very, very well. So, and to practice even more, you can try to create codes of your own, and then you can try to do the dry run. And if you want to cross check, you can always type your code on BlueJ and cross check. This way you will be able to do recursion properly, and any code you'll be able to handle. And even while writing your own programs, you'll be able to use recursion. So that's it for today, everyone. Thanks for watching. And if you have any queries or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.